Okay, so can you do like a brief, like 1 minute intro of like who you are, like what you're looking for, like things like that?
Mhm. My name is Matthew. Um, I'm just a recent new grad. I'm looking for really anything in like software engineering. Right now I'm doing like web development, but I'm trying to find something better. So I've been practicing my lead code, practicing my interviewing skills, so hopefully get a better job. So
Okay.
yeah.
Okay, cool. All right, so let's get started. So I will paste a problem here. So right now it's 7:05. We'll go until 7:55, and then I'll give you feedback. Oops. All right. So
Mm,
give you
more, I guess, yeah. For one
this.
hour. Mm,
Okay. And let me know if you have any questions and so on. And you are going to be allowed to run your code. So yeah.
Okay. So you're given an n by n binary matrix grid, so zeros or ones. An island is a group of ones representing land connected four directionally. Uh, yeah, oh, I've already seen this before.
Okay. Let me give you another one.
Um,
Okay. Let's do this one.
okay, okay. Given a string S which represents an expression, evaluate this expression and return its value. The interdivision should truncate towards zero. Range, okay. 230 minus 231, 231. You're not allowed to use any built-in function in value strings by command code. But am I allowed to use? Oh, okay. So I'm given the string.
Hmm.
Am I allowed to use int, right?
Yes.
Like the int.
Yes. You just can't use
Oh,
some
okay.
function that like takes a string and does an evaluation, but you can convert numbers if you want to. Yeah.
Okay. So example. So, huh. Will this expression have parentheses
No.
or like okay? And I see here. Okay, and I'll have to manually figure out the order on my own here. Because here, I can't just follow 3 plus 2. Yeah, I have to do this first. Oh, okay.
Yeah. So it can have numbers
Follow.
or plus, minus, multiply, divide, and you have to figure out the order on your own because there won't be parentheses.
Okay. Uh, yeah, I want the mean result to be in this range, so I can always just store it. Okay, so the question here is I need a way to figure out the order of operations here. How can I do this? Mm, hmm. I guess I could maybe do 3 plus 2. Okay, I might need something like a stack here or a queue to maintain some order here. Proper order of these operations. What I'm thinking right now, I could do, for example, I could go from front to back, 3 plus 2. But if I meet this, I know this must come before this. So then I could add that. That must happen before that. Hmm. Can I break this up? Uh, okay. essentially every time I see something, plus C times 2. Start off by breaking this up into 3 plus whatever comes after. And then now I need to handle this. But the thing is, yeah. So anytime I meet, I have to do this recursively. Um, anytime I meet um an operation, I know it will be something on the left with plus something on the right. So I need to evaluate something here and plus something here. Um, so if I meet plus, then I'll split it up like that in these two halves. Okay, I'm gonna have to recursively do this. Um, then if I have the other half, if I have the operation, then no whatever is on the left stays the same. But I need to determine what's on the right. Okay. So I'm currently thinking of a recursive solution here. I could just break this down into smaller and smaller parts. Uh, without something more complicated. I could break this up into 3 plus, and then this would be the triple dots would be equal to this, which could be broken down into 2 times something on the right. Yeah, and then what on the right here would be okay. I think I have an idea of a solution here.
Okay.
Um, I think what I'm going to do is I'll begin. So I'll iterate from the front to the back, and I'll collect the number. And whenever I meet an operation, um, I'll split it up into 2 parts. So I'll have the number, and then I'll add whatever the solution to this right part is. The thing is, I might not know what the solution to the right part is, so I have to recursively go recursively get the solution to the right part. Um, so it'll be like some sort of recursive solution where I'll be splitting up whenever I get a value, I'll split it up into 2 halves. I'll have whatever came before, which is just this value, and then all the stuff that came after.
Okay. So it looks like in your
Mm-hmm.
example you have this like 2 times something, right?
Mm-hmm.
So in that case you would basically get like this part. You see the part I'm highlighting
Yeah,
recursively, and then you do 2 times that.
yeah.
So that wouldn't be right because, uh, like like basically you're saying I'm doing 2 times this, which is not correct because you should be doing just 2 times 2 minus, right? So how can you take your approach and change it to handle that case? Basically, like whenever there's a multiply and a divide, you need to do like what? I guess. Do you see
Um,
how what I said makes sense though? To even
yeah,
make it
I
simpler,
see.
if you just do like 2 times 1 plus 2 times 3, like this wouldn't be correct. Like you would just do 2 times 1 and then you do plus 2 plus 3. so on.
Yeah.
Okay.
Um, hmm. Okay, so I know if I have a multiplication, I can always do a multiplication, right?
Mm-hmm.
If it's a multiplication here or if it's a division here, I know I can always do it.
Mm-hmm.
So I could go ahead and do it. The problem becomes if I have a plus or a minus. Um,
Mm-hmm.
so if I have a plus, this is where I have to do this if I have a plus. Um, if I have a plus or a minus, then yeah, I don't know exactly what this other half may be because of the order. So I'll have to do this recursive process if I have a plus or a minus.
Okay, and then what would you do for a multiplier divide?
I could just instantly do it. So
Okay.
if I can always run a multiplication or division.
Okay, so basically now you're saying you're gonna run the multiplication division like if it's there right away, and then for the plus and the minus, then you'll do the recurse on like the last part. That's what it's gonna
Yeah,
be. Okay.
yeah.
Okay. Yeah, I think that makes sense. And then what would be the time complexity of that approach?
That would be O of n, where n is the length of this string here. Yeah, yeah. And then uh space complexity would be O of n as well
Okay.
because
And
of
why the
the
space open?
recursive because of the recursive stack. It could grow down because yeah, it could go down as deep as if I have a bunch of pluses, it could just keep growing as deep as the amount of pluses I have or minuses.
Yep. Okay.
So
Yeah, I think that makes sense. So if you have anything else, you can add it. Otherwise, I'm good with you to be coding.
okay. Mm, mm, so I'll need some index on where I am.
Okay.
Mm, yeah, I know the base case. Hey, I need to do the recursive case right now. So if first I need to collect the number. Um, mm, mm, what is it? S plus it's numeric. Is this function? Is alpha? Is numeric?
I think you ran
Is
into this last
digit?
time. It's is digit lowercase.
Oh, okay. 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 So if well that's the case, then num dot append s of index. Um, and then Oops. No, balance equal to means. Uh, now, um, I have to check whether or not the operation is division or multiplication. This is equal to, okay. Oh, was it? Yeah. If it's equal to this, or um, so this as if index is in this, then I know I could run it. So um, then I'll need to get the next number. Mm, yes. Wait, so should I just recursively try this one again? Should I do this here? Oh, I guess I might as well. The expression is guaranteed to be valid, right?
Yeah.
Okay. It's equal to this. How is uh, oh, I didn't even notice. I would put that there. And now that append that. Um, whatever. Okay. Return. Mm, second oh, what is this? Second number, I'm second number. Oh, okay then. Okay, so if it's not this or this, then I know it needs to be a plus or an addition here. So then just return the plus 12 best or um mm, yeah, so I need to handle my base case now.
All right.
So um eventually I'll get to some position where I'll either okay, let me think about this. So if it's a multiplication, I'll get to a position where I have nothing left. So if I have nothing left, that means I must have the multiplication. Um, hmm. Wait a minute. Since I know plus something. So if I only have mm, it's another S or and then I could just return one. Does that mean I must have had a multiplication, right? If I get that done. Okay, now if I had an addition, um, if I had an addition, that means I'll have, so I'll end off with, or addition or subtraction. An addition or subtraction, that means I'll end up with, I'll have that plus that. Wait a minute. I can handle this, yeah. Maybe this should just be my base case. And then, um, I'm missing stuff here. Um, if my index is less than, yeah, if my index is less than, number, um, Yeah, let me try and go through this.
Okay.
If I have nothing left, that means I had a multiplication, so I know I could just return. Should I just return one? Because it's looking for that times that plus the result. Nope, so I need to actually return zero there. Yeah, I actually need to return zero. Um, no, it's out of bounds, return zero. Now I get the number. I have to survey. While my index is less than S, and S of my index, while it's a digit, then I just keep appending, increasing, and I get the value. I see if I have anything left. If I have nothing left, then I know the value of this expression is just this number, so I'll return the number. If I have a division or multiplication, then I get my operation. I'll go one step ahead. Now I'm trying to get the numbers. Um, at the next number here, because I know if I have a multiplication, I'm guaranteed to have another number, either of these. The same to get the value. If it was multiplication, I multiply them, get the rest. Um, should I be doing plus one here? Oh, and I don't know if it change this to index two or no, the same index, yeah. Index is less than is digit. I need to do this as well. Second num value is equal to the integer. Uh, yeah, that's correct. I need to make sure that go get the next. Uh, yeah, this plus one is necessary. This plus one is necessary. If the value is if it's positive, return this numerical value. Solve there. If it's that should be minus. Okay. I think this is good.
Okay. You want to test it?
Sure. Let's try something a bit more complex.
Okay.
Oh, I'll just create it myself. Hazard 3 by 3 plus 2 times 4.
All right.
So I have a division, then I have an addition, then I have a multiplication. Okay. Hmm. Shouldn't index out of range. How is that even happen? If index is If index is greater than length of S, and I return the numerical value. So how is this?
So this is off by one,
Um,
so I can just tell you that this and this is off by one, right?
sorry.
42 and 53 are off by one and should be greater than or equal to, right? Equal to is out of bounds as well.
Oh, yes. Oh, I forgot about this. Okay. That'll be the same thing here.
Mm-hmm.
Then make that somewhere else. It has to be less. Okay, that's correct. 10. 3 divided by 3 is 1. What is this? So then I'll do 1 here plus 2 times 4, which is 8. 8 plus 1 is 9. Minus 1. Plus you giving me 8. It's giving me
Mm-hmm.
10. That's not correct. If it's digits, uh, I'm let's solve as index plus 1. Um, hmm, there's this one going out. So 4, 7. So 3 divided by 3, 1 plus, yeah, I'm getting 10. So, um, plus minus, there. And I return now, or now divided by this. And 3 plus solve over here in next year. An error with that logic. Solve 2 times 4, then I'll get 1 plus 8, 9. And when I get 8, then I'll do. Oh, wait a minute. This minus 1. Um, I'm skipping the minus 1, aren't I? For example, when I'm doing this, then I'm just skipping over this last operation. So I'm actually not considering whether or not this sign is positive or negative. I need to consider it. Um, One way I could do is I
Oh
could,
yeah, you're always doing plus.
mm-hmm. And then the numbers could be negative. Oh, the numbers always, can the numbers have like a negative sign in front of them?
No, you can just have positive numbers and add and subtract, and that's it. But yeah, like here, you're always just doing plus, even if it's Or are
Yeah.
you handling negative anywhere? You are, right? So what would happen here? So you'd get like one, and then you'd recurse to this case,
Mm-hmm.
and then
And then
there, what would you get? Like
here I'd get 2 times 4, which would be 8. And then I'd skip over this negative because I'm doing index plus 1. And then I'll just return. this one here. So that's why I'm getting 10. Um, I need some way to. uh, So I need to not do that. I need to consider my next operation as well.
Let's move on to the second question because we only have 15 minutes left, if that's cool. Unless you want to
Okay,
just do this one and that's it.
I'll do the next one.
Okay. Okay, so here's the next one. And once again, if you've
Given the
seen it, I
network
can
of,
change it.
oh, given the network of n nodes labeled from 1 to n, n times a list of travel times is directed edges. So from node to node, we will signal from the minimum time it takes for all the n nodes to receive the signal, and it's possible for all the n nodes to receive the signal return -1. It seems like a minimum spanning tree question or a Dijkstra's question here. Is this minimum spanning tree given minimum time it takes for all the n nodes to receive the signal? Okay, so no, this is not minimum spanning tree. I think this is just Dijkstra's. Uh, I need to find the shortest. Oh, I need to find the longest time. The longest minimum time. Okay, so um, for this question, I think I'll just run Jack's just this algorithm to find how long it takes to get to each node,
Okay.
and then return the maximum time of those.
Okay, so would you run from from k to each node? Like, so if there's like n nodes, you would run it like n times.
No, I'll just run it once.
Okay.
So I'll run it once to it's from K. So I'll just
Okay.
run it once from K, and then I'll figure out which node took the longest to get to, and then I'll just return that answer.
Okay. Got it. Sure.
Okay.
Yeah, I think that seems fine to me. And we are a
Oh,
little short on time, so you can start coding.
okay. Um, so I'll have I'm given my node K. So I'm guessing
So you're
well,
given
I'm
times
given
n and k.
the nodes are labeled from 1 to n.
Mhm.
Um, Let me go both ways. Directed edges. No, you can only go one way. Wait a minute. Times are positive, so yes, I can run dextrous and then directed edges. This also works with dextrous. Okay. Um, so I'll just do this. That means I can only go one way here. Okay. Now I have to run back to this. Um, um, then Daxus also uses. Does Daxus use a Q as well? No, his Daxus only uses a he. Oh, I think it uses a he. Okay. So I guess I'll start off with the source node, or we'll have it kind of zero. Mm, just look in. Hmm. How many nodes do I have exactly? Uh, my GNC live give me how many nodes I have? You're given a network of just n
Yeah, so you're
nodes.
given an n. You're given times n and k.
Oh, okay. Mm, mm, okay. And then, oh, technically I need to do distance of source. So it goes from 1 to n, so I need to do -1. Um, distance of source -1. Why did I do like this? So, min heap. Now, pick the min. So, equal to heap pop min heap. Now I'll be storing time number one, or the distance, and the node. Um, okay, so I pop off. Now I see if that distance is less than or equal to distance of a node, or if it's greater than, uh, I can continue here. Else I need to update or relax. Yeah, I need to relax all the neighbors here. So for the adjacent view, so for V in um mm, this equal to this, yeah. What was it? Maybe I should do it the other way. Distance plus time, and then distance of v. See, I don't want to be dealing with all this stuff. I'll just make sure I pass in the correct values. Distance of v. We can relax this. And then now, after it's relaxed, I need to add this. Hmm. That's and then we push and we new distance, and then there's no v. Uh, we'll do this in a little too. Distance is less than. Okay, so if new distance is less than what it currently was, then I update it and I put this under the heat, and then uh like this. Source would be K passing -1, and then that's all it's expecting. Uh,
All right. Uh,
synchronous. Huh?
oh, you called distance and distance, so you have to change this.
Oh, distances. Why is it giving me that?
I'm gonna get an S here too, and
Oh,
then okay. So maybe try running this and see if it works. Since we're kind of low on time, we have like a couple minutes left.
oh. So, okay, so I'll have, let's do one. So I have one going to two, at a rate of 1.5, two going to three, have a percent of two, and let's have one going to two, percent of two here. One, two, and then I'll start off at one, and n will be equal to three.
Okay, so you have 1 going to 2, 2 going to 3, and then 1 going to 2 again.
One going to two. Yeah, two going to three, and then one going to two. Wait.
So this is the same.
Oh, I meant to.
Okay. And you start
Okay.
at 1 here.
Yeah.
Okay, so this should be, let's
Uh,
see, 132. This
that
should be
should be.
2.
Yeah.
Okay. And what did you get? Or you didn't print it?
Uh,
Okay.
what time right now? If n is two, I have two nodes. One, two. Why is one of these not updating? One is going to two, two is going to three. All of them are being touched from one. And then heat plus making interesting to me. I don't know where this is going on.
Yeah, this one definitely seems harder to debug. Like, I'm not sure. Like, I thought this would have worked. So, not entirely sure. Okay, but we can stop here. I think you're, like, at time. So,
Okay.
okay. So, how do you think you did?
Uh, not too good.
Okay, that's fair.
Um,
What do you think you did the worst?
it's I think this one I had the right approach a lot quicker than I did for the first question.
Mm-hmm.
I got really messed up on the first question. I have the wrong. I know something went wrong. It shouldn't be this long and complicated. So
Mm-hmm.
I know it's probably an easier way to do this question, but I couldn't think of it.
Okay. So,
Um,
yeah. So I think the main thing you did wrong, honestly, same as before, you never really ask about input constraints and edge cases, and there were a lot for the first one. So, and you mentioned them like down the road, like after you were like halfway done coding, like numbers can be negative. What if you divide by 0? What if you get decimals? How many digits can be in a number? Can it be valid? Like all these things. Um, and that's going to affect your solution a lot, right? Like,
hmm,
so well, I guess they told you it's valid, so that one's fair. And they did tell you that like, yeah. So I guess maybe like you don't have to divide by 0, but I don't think they said, yeah, the negative one they didn't say. Um, and you asked that later on, so it's like
mhm,
you weren't sure, and I think those things you really want to clarify, especially in a problem like this, because it's going to change it a lot. Like if I could do 3 plus -2, or if I can't, that's going to change your solution a lot. So the
mhm,
better approach, and you were kind of close. Like I think you can do it with recursion for what it's worth, and I think you were pretty close to a solution. And I will say this is definitely like a definitely a tougher interview, like one of the toughest I've done with people. So like if you would have just like blazed through this, that would have been like very very good. Because
mhm,
yeah, even though there is an easier way to solve the first question, it's not like an easy question in my opinion. There's a lot of annoying stuff. So you could have used a stack, and basically what you could have done was anytime you hit a multiplier divide, you could just like do that with the end of your stack and the current number. And then whenever you hit a plus or a minus, you can just like add the next thing onto the stack. So what you can do, for
mhm,
example, for a minus is for a minus or a plus, you can either put them on the stack, or you can just make sure that like the next result is negative if it's minus or something. Have like a sign, and that would have been easier. So like for 3 plus 2 or something, you could have been like 3 plus like 3 plus on the stack, and then 2, and then when you hit the times, then you know, like, I'm just going to multiply that with the next number. So you would
Oh,
get this. And then you just, whatever the thing is between the numbers, you just do that operation. And then that would work for
oh,
anything bigger as well. Uh, you also
question.
don't need the plus on the stack, but that's like one way to do it. Because basically,
Yeah.
plus, like, you kind of got the right idea. Plus and minus, like, it's just like whatever I have now, and then recurse to the next part. Because like that part, yeah, they're basically like separate results, and you can do it. So that would have been easier than the recursion. And you had a lot of bugs, and
Mm,
I wrote down like I think you have a lot of bugs here. You solved a lot of them, but this was a kind of complicated problem, complicated solution, so you weren't able to finish it. So
mm-hmm.
and I think people do struggle with like the string problems, like um, string manipulation, like all that kind of stuff. It's definitely not easy. Um,
Mm-hmm.
but yeah, that's the main one. So I think if you can do this problem in 20-25 minutes, that's like amazing. I think that's like, this is one of the harder problems. This is like a meta tagged question for what it's worth, so they do ask this. I think I know some people that get asked this for other companies as well, or some variant of it, like parentheses or whatever. Um,
Okay.
so yeah. Um, and let me see if I have any other notes. Yeah, so your time complexity was correct. Everything was correct. Your approach was good, but yeah, I think the two biggest areas are clarification. You almost never clarify like anything, and then your code has a lot of bugs, and you do end up fixing them, but you can work on like having a cleaner approach to begin with, so you don't have like 5 bugs to fix. I think you had this the other time too. You fixed them all, but you had a lot. So maybe try to like plan it out a little bit better, and then that way you have a little bit less. Like what you could have done,
Okay.
for example, is before coding, you had some approach, right? That's like I'm going to recurse or whatever. So what you could have done was like a dry run of your approach with one of these, and then you would have seen. I think another one that would have failed for you is if you just had like this, like infinite times, because you just assume the next thing is a plus, and then you just like add stuff. So that's another like edge case I think that would have failed for you, even if this thing would have ended up working. Because basically you said like if it's a times or divide, then I'll just do that now, but then I'll add the rest, and then so you can have this like chain of multiplies and divides that your code would have broken as well, even if the other stuff would have worked. But that's that's
Okay.
that's one thing I would recommend is like so you make a plan, and then pick a like an okay difficulty like example, and then just run your plan through like okay, so I'm saying I'm doing this now. I'm gonna take like this 3 + 2 × 2, run it through that like what I think, and do I get the right thing? And then if it does, then you can code. And that helps a lot because that way you can identify if like your plan that you picked is actually working or not. Does that make sense? So
Okay.
kind of do like a dry run before coding, especially for these more complicated ones.
Mm-hmm.
Okay, and then for the second one, and then obviously, yeah, your code for the first one was a little bit not super clean, not the worst. Like honestly, if you would have had a great solution and your code was super clean and it worked, that would have been like pretty ridiculous for not having seen this problem. So like, it's kind of hard to have
Mm-hmm.
everything correct, just because I think the difficulty is a little bit higher for this one. Then for the
Mm-hmm.
second one, you quickly identified Dijkstra's, which was good, so you're familiar with like more complicated um, algorithms, and I think Dijkstra's is probably as hard as it gets for like interviews. So once again, you also didn't clarify any input, but there wasn't too much. Like some things I could think of, for example, is like what if you have duplicate edges? Like what would you do? So that's probably an important one, because then what you would have done is like would it work for that? Maybe, but I would clarify that, and then you could have just handled it. You could have just said like keep the smallest edge or whatever when you make your adjacency list. So I definitely work a lot more on that. Just like clarify inputs. It's not leak code. Like don't assume they give you everything. And I on purpose tried to be as vague as I could. So you would ask, but you asked some stuff, but it
Oh,
was yeah. And that's also
okay.
something people do as well, is like they are like, maybe leak code gives you like 5 things, they'll tell you two, and then they expect you to ask other stuff. Because you want to be able to like they want to see like are you just jumping in, or are you trying to figure out like what are the things that could go wrong? Um
Okay.
Yeah, and then your code was great, I think, for this one, honestly. I honestly don't know what your bug is. Like, I'd have to think about it.
Mm.
You also wrote like a very optimal Dijkstra's. You could have made it like little changes here and there, but it was like you basically never added to the heap unless the distance was smaller. So that was like very good. And yeah, like honestly, even though your code didn't work for the second one, I would probably mark that close to like a strong pass. Because there's probably some stupid
Mm.
thing that's like whatever. It's not super important, you know, and it's kind of hard to debug Dijkstra's. You probably can. That's another thing, I guess, thinking about it. So if you are allowed to run your code, think about like how would I add logs into my code, and then I can like run it and for like a small thing, and then figure out like that would have been good, especially for like the first problem. You could have definitely done that. You could have like added logs, ran the code, seen where you are, because it's kind of hard to visualize everything once the problems get complicated. So being able to add logs and debug is another skill that is important. Um,
Okay.
yeah, and you could have definitely done that for the first one, right? You could have been like, okay, I'm gonna print like
Yeah.
where I am at the start of the function or whatever, or like what's my result, and you would have clearly seen like the problems quicker. Um, and yeah, I think that's the main stuff. So I will say this was like a harder interview. So I would definitely say like probably this is an on-site. I'd say like, or I guess I can go through all the like. So there's like the four parts that I talked about. I think I mentioned with you, but basically there's like problem solving. Like how fast can you go uh, from a problem to like a plan without the code? And I think you do pretty good there. Like for the first problem, you had a
Mm.
decent plan. Um,
Mhm.
yeah, like for the most part. And for the second one, you basically came up with it instantly, and I think that's the hardest part for people. Like, if you can't come up with a algorithm quickly, then like there's not much you can do. But if you can do that, then the other stuff is like more easily fixable. So the next part is like coding and code quality. I do think you struggled there, where like you always have a lot of bugs. Um,
Okay.
so that's one I would definitely work on like fixing. Like maybe have a more concrete plan and then code. And then the other one is like communication. And I think your communication's fine. You basically explain everything. So I'd say it's like really good there. And then the last one's like knowledge of like DSA. And I think you're also very good there. Um, so
Mm.
I would say for like a tech screen or something, this would be a pass just because these are like harder questions. And then for an on-site, like depending on how competitive it was, it would probably be like a fail or like another interview. Because the way I see it is like I knew I asked you harder stuff than most people. So then the bar to like how well you do is going to be lower than like if I asked you, you know, some like top K or whatever simple thing that you can do in like 5 minutes. And I think that's pretty
Okay.
fair, right? Like the harder stuff I ask you, the worse. Like you don't have to do perfectly unless it's like Citadel or something. So um,
Mhm.
but hopefully that gives you things to work on. Basically, just like code
Well,
less bug free,
yeah.
and then yeah, clarify stuff a lot more. And the nice thing is, yeah, you definitely know a lot of algorithms. I don't know if you've just like done a lot of leak code or you studied a lot, but I'm guessing you're familiar with like basically every algorithm you need to know for like interviews. I don't think they ask anything more complicated than this. Maybe like DP. I'm guessing you know DP as well if you know this. So
Yeah.
yeah.
Okay.
So
Okay.
basically, yeah, that's the things I'd work on. If you want to do another one of like these type of difficult ones in the future, let me know. But I think that's where
Okay.
I would try to hit the bar is like try to get an interview like this and just like smash it. And if you can do that, then you can basically pass everything. Um, yeah.
Okay.
Okay. And then do
Okay.
you have any other questions or good?
I think that's it. I'll just work on my coding,
Okay.
implementing stuff quicker, and
Yeah.
having less bugs and clarifying edge cases. I plan to do that, but I must have forgot. When I get lost in the weeds, I forget
Yeah, and that's the other thing is
things
like
that I have.
it's very easy to like remember the things, but once things don't go like once things aren't according to plan, because like when you
Yeah.
did the first problem and I was like let's move on, you didn't finish. It's hard to like stay focused and like you know and like do well still because you kind of lose motivation and like whatever. It's hard to do well when like things don't go well during your interview, basically. So yeah.
Yeah. Okay.
Okay, cool. All right. Well, I'll
Okay.
talk to you
That's
later then.
everything.
Good luck.
Thank you.
All right. See ya.
Bye.